Hello and welcome to PCMINR.com, and you're watching this video on important concepts of electrostatics for grade 12 by Sonal Gupta. And I strongly believe and I find that the harder I work, the more luck I seem to have. And in this video, we are going to discuss about electric field on the axial line of an electric dipole. Now first we need to know what is the axial line of a dipole. See, a line which passes through the line joining the centers. Now this is the line which joins the centers of two equal and opposite charges. These are the two charges of a dipole. So if we continue this line further, this is an axial line of the dipole. So we have to find the electric field at this point. So we assume here we have a charge minus Q at the point A, and here we have a charge plus Q at the point B. And we want to find the electric field at a point on the axial line of the dipole. So P is a point which lies on the axial line of the dipole at a distance r from the center of the dipole. So from the center of the dipole O, we have chosen a point P which is at a distance r. Now if the axial line of the dipole is of the length 2a, so that's 2a is the total length of the dipole, then each half is a and a. Now we need to find the electric field strength at P. We will find it because of the dipole will actually be found out by two charges separately. So first we find out the electric field at P due to the charge at A, that's EA. This electric field is equal to Q upon 4 pi epsilon naught r square, which we've just done the formula, 4 pi Q upon 4 pi epsilon naught r square. Now but what is my distance r here? The distance of this point P from A is r plus A, because this will be added in it. So I have Q upon 4 pi epsilon naught A plus r, or r plus A whole square, and because it's due to the negative charge, it will be directed towards the left, because the electric field due to a negative charge is directed towards the charge. So EA is along this direction, that's towards left. Now what will be, okay, we can mark this as equation 1. And what is EB? That would be, because the magnitude of charge is same, so Q upon 4 pi epsilon naught r square, but r this time will be the distance of the point P from the B. So that is r minus A, because out of the total distance I have to subtract this distance. So this distance would be just r minus A. So r minus A whole square. So I have these two equations, and this field on the point P due to the plus charge will be acting towards right, because the field due to a positive charge is away from it. It is directed away from the charge. So EA is towards left and EB is towards right. Therefore, the net electric field at P is going to be E, will be the difference of the two, that's EB minus EA. So we'll just substitute the values and find. So when we substitute the values of EA and EB, Q upon 4 pi epsilon naught is taken out common, and we have 1 upon r minus A whole square minus 1 upon r plus A whole square, and the LCM would be this Q upon 4 pi epsilon naught outside, and inside the LCM is A minus B square. So we have the product of the two, and A minus B into A plus B is A square minus B square. So I have R square minus A square whole square as the LCM, and when I'll substitute the values, because this side I'll get R plus A whole square, that is R square plus A square plus 2AR minus, I have R minus A whole square, so that will be minus R square minus A square, and minus 2AR multiplied by this minus would give me plus 2AR, and so these cancel out. I'm just left with the expression Q times 4AR upon 4 pi epsilon naught into R square minus A square. So we have got the expression as E is equal to Q times 4AR upon 4 pi epsilon naught R square minus A square. Now we can write, we can just split this 4A as, so we can write this as 2QA, right, times 2R. I would still get the same thing, 4QAR. And 1 upon 4 pi epsilon naught, I'll just write it as K, and upon R square minus a square. Now I know that 2qa is the dipole moment P. Therefore the result I get is that E is equal to 2r into P, k times this, upon r square minus a square, and the direction of this field is going to be along BP. So this is the field along BP. That's the net electric field at the axial line of a dipole. And if I have a special case that my dipole is very, very short, I mean for an extremely short dipole, this distance A would be ignorable as compared to R. Therefore this whole square, which is, we can write it as, we can just omit this a square, so it becomes k times 2rp upon r raised to the power 4, because I've just ignored a square and 1r would cancel. Therefore I say the net electric field on the axial line of a short dipole is 2kp upon r cube. Thus the electric field of a very short dipole varies inversely as the cube of the distance of the point of observation from the center of the dipole. I hope you find this video helpful and you're clear about how to find the electric field on the axial line of an electric dipole. So if you find our video helpful, please like us, subscribe us and follow us on Instagram and Facebook at PCMINR.com. Thank you for watching.